Hey everybody, Jay Weidner, Reality Check's been a while. Glad to be back. A lot of stuff going on with JFKX and doing a lot of interviews and things. And finally got kind of breaking out, I guess, after a long time of nobody really paying attention to it. So, anyway, that's good news. And we're back today with Ken Schwartz, of course, the founder of Purple Power C60. Great stuff if you want to get healthy and take it every day. I do. And it's a magical substance, super conductive and uh, just great stuff. Anyway, uh, Ken, how you doing?
Doing pretty good. It's finally above freezing here in in the Denver area.
Yeah, we're actually warmer right now than we were. The El Nino kind of comes up, just brushes up against southern Colorado a little bit, and brings in some of that warm, moist, weird air from El Nino, and so we have that going on. But we did get it cold. It was 3 below 0 this morning when I woke up, so freezing cold for sure. But it's global warming anyway. Hey Kent, so you're telling me about this thing that you work on or you know about or you invented. I wasn't quite sure. MOXY.
Yeah, it's MOXY Fusion. That's MOXY Fusion.
Yeah.
And if anybody, we'll talk about it. But if anyone interested, just type in MOXY Fusion and then ResearchGate on Google, and it'll take you right to the paper. And well, anyway, you got
Yeah,
screen
that's
share.
cool.
You can read it yourself. The yeah.
Yeah. And so what the hell is it?
Well, what it is, it's a I'm going to probably gonna have to show some stuff, so maybe I'll back it off there. Yeah,
Okay.
it's C6 MOXY Fusion. It was originally, well, the type I use, it was originally discovered by these two guys named Osawa and Kushi in the late 1950s and early 60s, even before I was born. And but they did a lot of research, but they're kind of seeing it in the yin and the yang. And like on the one side, like sodium is yin, and then oxygen would be yang, or however the reverse it is. And what they did is they basically made what you might call a sodium street light, but they used a power supply and they made this chamber.
Yeah.
And what they did is they filled it with argon, but they also put a little bit of sodium in and an equal amount of oxygen. And then they turned it on, and what happens is, of course, there was a small quartz window that you could look into. It is pressurized because it's got to get pretty hot and power and pressure in there. And you could see, of course, the kind of the yellow orange of the sodium glow, right? We've all seen the sodium streetlights, but over several hours, that glow turned to a purple color. And purple is when you ionize in the next, the atomic family, it's potassium. So if you actually take a look, if you actually take potassium, which has atomic weight of 23, and you fuse it with oxygen, which has an atomic weight of 16, you make potassium with an atomic weight of 39.
Right.
And they made it actually a really efficient manner. So they essentially were doing fusion and that was kind of their prime experiment that proved it. They did a lot of others. That's not the only one, obviously, but that's the one that was kind of like the defining experiment that would prove fusion. Because here is a sodium and oxygen and argon, and then it turns into potassium. Well, that's pretty conclusive, and you could see it in the spectra. Now I was in the right place with the right people at the right time, and we basically redid their experiment, but instead of using and it's called metal oxygen fusion. That's what MOXY stands for. Instead of using sodium, which is, sodium hydroxide is kind of corrosive and nasty to work with, what we did in the same atomic family as hydrogen, and we picked deuterium, which is a hydrogen atom with an extra neutron, and then we used oxygen in an argon atmosphere, and with electrical discharge, and we had a multi-band spectral analyzer in it, and we were able to, what we basically did is when you turn deuterium and oxygen turn into fluoride 18, and then fluoride 18 would electron decay into oxygen 18, and electron capture decay. And and we had a multi-band spectral, like 50 channel multi-band spectral analyzer down at TSA Systems. It's a radiation detector, can detect 50 different layers of bands. And we could actually see the spectrum of, of what we were doing. And one of the things is metal oxygen fusion. It's totally different from the common fusion that people know of, the high energy fusion. And it's kind of in that Lehner zone, but this is what's actually happening in Lehner, not some, because this one is easily reproducible. And of course, we applied for a patent, and the patent office said, well, it's insane. We're still fighting with them. But and we posted, this happened a long time ago, I think 2011. And we posted our paper in one form or another. It's been up on ResearchGate since about 2014. And so another group, the Scotia group out of Scotland, they were working with the University of Valencia, and they basically redid our experiment. But and that was one of the things the patent office complained about. Oh, there's no third-party verification. Even though we went over to TSA Systems, their transportation security system that makes the stuff for them. But that's not good enough, I guess. Okay, to confirm it there. But these guys, they basically did the same thing, except for them, they didn't use a multi-band spectral analyzer. They use what's called a glass bead detector, and it can detect ionizable elements like fluorine. And so they basically put it in there. You got oxygen, you got deuterium, you got your argon, pressurized gas. They turn it on, and all of a sudden, fluoride appears, which is proof positive. This is totally separate. We didn't have anything to do with them. They just basically redid our experiments, and that's what they say science is about: redoing experiments. Well, that's what they did. But the thing, when I did the paper has like 7 examples of other people doing it. And I think the best one is if you go up there, MOXY Fusion ResearchGate, just type it into Google and they'll bring it there so you can go along with this and see what I'm talking about. Let me get to page 30. And this is really one of the this is what was done by in 2004, a couple of guys named Sedelio and Yorio, where they basically were using tungsten. You guys could see it, of course. They were using tungsten electrodes in like electrolytic thing, and if you can see here on the things, they have like the little. That's a spectral analyzer of the results after the experiment was over, and you could see the appearance of gold, of rhenium, of thulium, and beryllium. And so they basically, that's people always wanted to turn baser metals into gold. Well, here it is. They turn tungsten oxide, which into basically gold. But tungsten comes in 4 different isotopes. So they produced like rhenium, which is also like in the same it's in the same electron shell level as gold. So there's gold, there's platinum, there's rhenium, but they produce in one of the experiments they produced a little osmium. And what's really interesting though in this, it would build it up. They put the oxygen onto to the tungsten, but it's unstable. The daughter product's unstable, so it decays back into to gold or these other forms. And also, but what's interesting, they discovered beryllium, and beryllium is only created when atoms fission, like in the breakdown of like uranium or plutonium or neptunium or one of those things. When they break down, one of the side products they often produce is beryllium. In fact, all beryllium produced in the universe comes from fission reactions. None is produced by fusion. It's just by the very nature of beryllium. And that was present there. And then also atomic.
It comes from atomic bombs, you're saying?
Yeah, exactly. Yeah, it has to break things apart. And then there's also thulium, which has a lower atomic level than tungsten. So not only we were getting fusion, we were getting like a fusion fission where the tungsten was breaking down and producing rare earth metals and things like beryllium.
But what was the purpose, though, was to create more energy than you put in.
That was my experiment. This guy's was they were just doing the experiment and they found a way to produce gold and rhenium and
an accidental afterthought of the process.
Yes, but not everyone was that. There was another guy named Dr. Bass, and what he was doing, it's on page, the second to last page, whatever it was down, if you find it in the paper. And what he was doing, he was actually using kind of a similar electrolytic cell that these guys were doing, a little lower energy. And he was taking 1 gram a tenth of a gram of thorium, And with 300 watts, he could break it down into isotopes of tin and copper, kind of unique isotopes. Isotopes, by the way, they have the same proton number, but different numbers of neutrons for the people out there. And so they were kind of unique from what's made in nature. Unfortunately for Dr. Brass, he didn't understand that he didn't do his atomics right. He didn't understand he was also producing a highly radioactive gas, noble gas, which he was breathing during the experiments, which is why he's the late Dr. Bass.
Wow. So then you're actually, with this process, you're actually creating rare metals.
Yes, and there's another process that you can actually use zirconium hafnium oxide. That's the zircons on the beach, something like, some beaches that are made from granitic sands, they're like 20-30% zircons. They're really hard. Grind those up. You can get zirconium powder for about 50 cents, and you can fuse it into pretty much all the platinum group metals. And if you do the energy cost value, it's about $60 an ounce to produce gold or platinum group metals using MOXY Fusion. That's the inputs. Now the machines cost more, but the electricity and the inputs, well, that's about $60-50 an ounce.
And so how come nobody's doing this? I mean,
Oh, actually, they are doing it.
$2,000 an ounce for gold right now.
Yep. Let's just say in some far away, there's at least a half a dozen major countries that are
Asian
doing this right now, and some are perhaps even imagining producing kilograms of gold and platinum group metals every week.
Well, that would have a severe effect on the markets. For sure.
Well, yes, it's basically, yeah, especially, the machines are really expensive now, but that comes down. The input costs aren't going to go up. So, yeah, that's a significant change in the way things are going to go coming up here.
How much does one of these cost, these machines?
Well, it matters. I mean, people can make one of their own. You can basically, all you need is the power supply from like one of those sodium street lamps. And they've replaced them all with the LED lamps. Yeah. So you can there's warehouses full of these power supplies you can get for cheap. And basically you just have a chamber and probably stainless steel, maybe put a ceramic sleeve in it, and then get a graphite. What you want to do is you want to get a graphite crucible. You can cut it out, which is graphite's a form of carbon, but it's electrically conductive. You put the anode on the bottom, the cathode on the top, and you discharge and you pressurize it with about 10 atmospheres of argon, and then you just zap the hell out of it, and it happens. So what's really happening is when you're making these pulses of electricity, you're making what they call solitons, which is an electron smoke ring. And so like even in the core of the densest star in our universe, there's always like one proton for every one electron, right? And protons weigh 1,830 times, 32 times that of the electron, right? Well, in these solitons, these electric smoke rings, the weight of the electrons is often over the weight of the baryons, or the protons and neutrons in that. And that creates a form of super degenerative matter, which lowers the Coulomb barrier, the barrier it takes to fuse stuff together millions of times. Now, your energy output is lower, but it's easier. It's millions of times easier to do. Yeah, your energy output's maybe 1/50th, right? But if you make it millions of times easier to do, well, it comes out in the wash. And so this is easy to do. I mean, we literally did it in our basement, but it's dangerous. And that's like, for instance, that's because what happens is a lot of you remember Fleischmann and Pons, right?
Oh,
Fleischmann and Pons. Yeah, they were doing essentially they were doing MOXY, but they didn't understand what they were doing, and people couldn't repeat it.
Cold fusion for those who don't.
Yeah, exactly. Cold fusion. Yeah. They can repeat this because once you know what you're doing, you understand it's metal oxygen fusion. Anybody out there can do it. They've already done it. There's countries all over the world doing it. They're making, kilograms of precious metals every week. So it's not like it isn't easy to do. And so my thing was to make electricity. You can basically the most energy production best is with oxygen and deuterium. That produces the most energy release. And so you boil water, run steam turbines, you've got electricity. That was why I proved that process, because that is technically and heavy water is everywhere, right? Heavy water is everywhere, and the argon, which is the moderator, That's like 0.9% of the atmosphere. So it's not only the ability to make all of these precious metals for relatively inexpensive, it's also decentralized energy production, where you don't need a coal mine. You've got water, you've got air, you've got energy.
Okay, for a layman, um, I'm pretty sure there's no such thing as magic. So how in the world can you take the starter chemicals and have it turn into precious metals? How
Oh,
can
well,
it?
what you do is you just you have to get the right ones. Like for what these guys, uh, let me say his name right, because Sedelio and Yorio, they just basically were using tungsten oxide in this. They were using tungsten, the oxide. The actual guy that discovered it was a guy named Ken Shoulders, Dr. Ken Shoulders. And he was making these solitons and firing them across like a vacuum chamber. And he'd fire it at this aluminum plate, and right, it'd punch holes in it, and that was kind of cool, but nothing happened until one day he put in an aluminum plate that had been lying around, right? And it had put an oxygen layer on it. And so when he punched the solitons into the aluminum oxide layer, and then they used X-ray spectroscopy to look at what the elements were there. He found elements which you would get if you fused aluminum with oxygen. So Ken Shoulders is kind of the guy that broke it, that it's this aluminum oxygen. That's what happens with Fleischmann and Pons. When you take, unfortunately for them, when you take, let's say, platinum or palladium and you fuse it with oxygen, you make, unfortunately for him, radon gas.
Oh no.
With the platinum and oxygen makes radon gas, and with the palladium and oxygen, it makes a radioactive xenon gas. And
I mean, so Fleshman and Pons were sucking this stuff up while
oh
they're.
yeah, that's no. What happened is when it came out, like I think Pons went back to France because he was a French guy, and they just abused those two guys just brutally.
Oh, they did.
Pons said, "Screw this." He's back in France.
Yeah.
Well, Fleischmann, he was an American, right? He couldn't go anywhere. So this is an example. And so this was actually discovered by another researcher who was doing one of those electrolytic Fleischmann Pons type things. So what he did is you probably in your basement, you've probably done, like, if you have a basement, you can do the radon test.
Oh
Well,
yeah.
inside in that radon can you get where you open it up, there's this little P34. It's like it's a plastic resin in there. And when an alpha particle, because the radon, it's radioactive and it kicks out an alpha particle. And if that alpha particle hits the resin, it puts a weakness in it. And then they take that little chip, it's a tiny, really, really tiny, and you put it in hot sodium hydroxide, and it etches out a pit. And so this is what this guy did. He only ran it for a few hours. And like, here's an example of what the chip looked like before he put it in. And you can see there's like one or two little holes there, right?
Yeah.
So that's the raw. Okay, after a bunch of hours of running the chip, that's what the chip looks like. All those little pits, those are all hits from radon. That's an alpha particle from radon. So basically, unfortunately for Fleischmann, who caught cancer and died, he was basically, imagine being, in the worst, 1,000 times the worst radon basement you could imagine. And the other thing about metal oxygen fusion, because it lowers the Coulomb barrier, it also lowers the energy at which the daughter molecules that you make emit energies. So instead of emitting in the gamma ray band, which you use a Geiger counter to detect, it emits in the X-ray band.
So you don't.
So these guys were walking around with a Geiger counter looking for gamma rays all the times they were cooking them with the and that's actually cooking themselves with X-rays. And that's actually how we proved our experiment. Is the first proof of it, besides the spectral band analyzer, which we did later, for the other one, is we basically, when we didn't have everything right, we used dental X-ray plates. Because my friend Gary Rodriguez, who was an electrical engineer, his brother was a dentist, so we borrowed his dental X-ray plates. And on the top, you see, when we didn't have everything right, the plate is white, right? There's no X-rays. But on the bottom is the black plate, and that's only like after a couple minutes of running the thing. That plate is totally saturated, which is actually why I found out about C60, because I figured this was going on, and I wanted to get an extra radiation protectant for my crew and myself. And so I discovered this stuff called carbon-60. Gave one set of rats got carbon-60, the other didn't. The control group didn't. They hit them with a fatal dose of radiation. The C60 rats lived. where the control group died. And so I said, that stuff's for me. So I got a couple of sources for my crew and myself, and we took it. And of course, just to finish up the C60 story, the experiment was fine. Everything was great. I kept using C60 because I got better mental clarity, more energy. I just felt better. And then about 7 months later, I went in to see my eye doctor, and my DRUES, or dry macular degeneration, was completely healed. And then when I learned about that, my friend Gary Rodriguez, he was an electrical engineer. He had developed severe wet macular degeneration because he had type 2 diabetes, which kind of they go together. So I made a preparation of C60 and MCT coconut oil, because medium chain triglycerides, they're carbon 6 to carbon 10s to carbon 8s. They can be turned by your liver into ketones really quickly. And if you got a glucose processing issue, you want to take ketones. And so he took a tablespoon a day for a year, and his severe wet macular degeneration went completely away. And I used to be able to post online the before and after pictures of his inside of his eyeballs, but some 3-letter agency said, "Oh, that's making a claim." So
Yeah, you can't
you
do
have to
that.
go to private seminars to see those.
Well, I know this. I had when I started taking the C60, which is about regularly, which has been about 4 years now, I was wearing 2.5 glasses to read, and now I'm back to 2.
Oh yeah.
So I have had an imprint, and I noticed it, and I was trying to figure out what it was. I was just saying, oh, maybe, was there something I changed in my diet, but now that I'm thinking about it, it happened just at that same time that I started, about 6 months after I started taking the Purple Power, I started getting better eyesight, which is pretty good. To only
Yeah.
have two power of 2 glasses, you know.
Now,
Um,
the carbon 60, it's also made in like the burnt wick of candles, are like 0.25%. And it's a black substance that increases longevity and mental clarity. Almost sounds
Really?
like that little philosopher's stone to me.
That's interesting you say that, because um, I was doing a study of plasma last week, and uh, this scientist was describing what happens when you light a candle, and how the wick um, causes the plasma, which is the flame. And he went through the whole thing, and how important the wick was to the plasma discharge, right? And I'm just wondering if C60, it isn't somehow associated with some kind of plasma
Oh,
discharge.
well, that's actually where it's made. It's made in the atmospheres of giant red stars for most of the universe. And giant red stars, by the way, they're stars like our sun, which run out of hydrogen. So now helium's fusing into carbon. So they're very carbon rich. And as the atmosphere bubbles out with all the electrical discharges into space, maybe about 0.1% of that carbon turns into carbon 60. So it's that. So yeah, there is something to do with plasma discharges, because it's made in the atmospheres of giant red stars. So yes,
Interesting.
that's where C60 comes from.
That's really,
And
really
whether it's a
cool.
candle or a giant star, it's the same process.
Yeah, very interesting. So can people, people can make these MOXY generators or
Oh yeah,
machines?
we actually built a bunch of them. They're little tiny demo ones. We've been giving them away to, well, we've been sharing them with institutions and governments who, here's a working. It's not like the other stuff. Oh, we can't get it. We can send you. We send them a fully working little tiny fusion reactor. It just makes a little tiny fusion flame, right? Just a tiny. It's like a fusion candle, but that's all you need. You get 10,000 candles. You can boil water, and it's easy to do. It's really easy to do, and it's all over. This cat is out of the bag. The horse has left the barn. For all of you suppressors of information, there, you guys are way behind. You wouldn't even approve our patent. Well, let me tell you, all those advanced nations in Asia, they are so far ahead of you right now that when finally, your horse is still in the stall, and they're on the winning track of the racetrack. So
Well,
they're winning.
let's get it going here in this country. So you're going to give me links, right, to people who can get these papers
Oh yeah, yeah. We'll give you links. Yeah, I sent that link up. Yeah, we could put some links in there. And actually, I went on Jeff Rentz and did like a whole hour on describing how to do it and things and what you get here, and it links you all the papers. And the other thing is, Stanley Meyer. I had a
Mhm.
friend who knew Stanley Meyer, and he, Stanley was very secretive. He wouldn't tell anybody what he was doing. But the only time his dune buggy was over Unity is when he used heavy water, deuterium oxide, and the non-combustible gas was argon.
Yep.
So it appears that
Remind everybody who he is again.
yes, Stanley Meyer was this guy back in the 70s mostly. That's when people know him. And he actually created this car that on times was over Unity. That means basically here we got this dune buggy. It's got one little battery to run it. They start it and it runs. And they had third-party observers watch this, right? This isn't just some dude making a claim.
Unity is when you produce more power than you're taking in.
Yeah, exactly. So he's driving this car that's running off, quote, water. It's electrolysizing water into its constituents, putting it into the combustions where it recombines, and it was actually producing more energy than came out. But one of the things is, see, we know what Stanley was doing because like normally the way you get heavy water is you use electrolysis and the hydrogen comes out and the oxygen comes out, but the deuterium stays behind. And so if I did like 7,000 gallons of regular water, I would end up with 1 gallon of heavy water. So you can't use electrolysis normally to do that. But what Stanley did, he made injectors. He made these fuel injectors so he could inject the heavy water directly into this. There was like a little tube with a little wire in it. And so the water would go in there and then he'd hit it with a blast of electricity and it would totally electrolyze it back into oxygen and hydrogen. And that would inject into the cylinder. And of course, the cylinder was full of argon gas and then it burned over. So literally, Stanley Meyer turned a flathead VW engine into a MOXY Fusion reactor and was driving it around as an over Unity vehicle. So if you any of the Stanley Meyer fans who have your working things, there it is. Get your argon gas. You can get that down at the gas plant. You can buy heavy water for $1 a gram from online, and away you go. So you turn your little Stanley Meyer imitator car into, or your electrolysis car into a MOXY fusion reaction. But be careful. It makes a lot of X-rays. So I suggest you buy some C60 to protect yourself against any of those extra X-rays.
And don't forget, and dental aprons or whatever.
Yes, dental aprons like that to protect those other important parts.
Yes, extremely important. So would you recommend someone do this?
Well, I couldn't. Well, they can. I mean, there's nothing to stop them. I mean, with the links that we have, with what I've talked about, listen to the Rent Show, read the paper. If you've got, if you're decent and you got an electrical engineer guy and an auto guy or basically a fabricator guy, you can do it yourself. You don't need me. This is all decentralized. Anybody, anywhere. I mean, yep. In the world could, with the reasonable, intelligent people can redo this. And it's already out there. It's been, tens of thousands of people have downloaded the paper and all the other stuff. So this is, and there's no way they can stop it.
So I could power my ranch with
potentially, yeah, you could power your ranch. Yeah, you just get heavy water and argon and a special generator, and yeah, you could various different ways you could power your ranch.
Amazing.
Or you could get zirconium oxide powder. You can buy that stuff, zirconium hafnium oxide powder from China for $50, 50 cents a pound, and argons, you get that the air, and there you go, turn it into gold. For 50 cents, it's like, Rumpelstiltskin is my name.
So you're powering up your house and you're getting gold.
Well, that would be a different thing. I don't know how much power you get. But what's interesting, Dr. Bass was getting, he could take, like right now when you do fission, you use burned uranium.
Yeah.
You get, maybe 0.5% of, or 0.6% of the uranium they pull out of the ground is uranium-235, and that's what they use in reactors and stuff. But with MOXY, you can burn 100% of the uranium, 100% of the thorium, the plutonium, the cesium. That's one of the things, is to break down atomic waste. Right. So you can burn it into non-radioactive metals, which are useful, and a short-term radioactive gas, which then becomes non-radioactive. So you can take atomic waste and completely neutralize the radioactivity and release a lot of heat and run an electrical generator off that.
Has
so
this
you
been
can
done? I mean, this is pretty amazing. If you
Well,
could,
I don't know. It may be doing. I mean, I don't know what all those countries are researching it, but I'm sorry, but the Five Eyes countries, the Six Eyes countries, dropped the ball on this one because it was actually a featured topic in South Africa at the BRICS meeting in one of the side rooms.
really, that's pretty
Yeah, so
interesting.
they all know it. They all got it.
So this is going to be emerging technology
Yeah,
then,
it's everywhere. Pretty
and
much everybody in the BRICS has it, and every wannabe BRICS countries has it. If they want to, they can do it.
part of the great decentralization that's happening. So, that's interesting. That's really interesting. So we can get rid of all the solar panels and the
Mhm.
hydroelectric dams and
Oh, yeah, but mostly you'll get rid of coal-powered fire plants and fission power plants, and it's very decentralized because all you really need, heavy water is anywhere. In fact, that's going to be the new the new type of currency. It's going to be called a deutero, and it's
yeah.
1 cubic centimeter, which is a little bit over a gram of heavy water. And because heavy water is denser than regular water, you can use like a hydrometer for like brewing. When you brew beer, you put more sugar, it makes it denser. So you can use a hydrometer to see the quality of your heavy water. And then you go down to the heavy water bank, and you can make heavy water like through electrolysis and a fuel cell cycling. So you
Yeah.
can just take water, turn it into heavy water, which is a fuel. Then you can take that fuel down to the deuterium bank, and they'll look at it, see its quality, and then they'll issue you electronically deuteros, which then you can take down and buy stuff with. And you can go anywhere in the world. And if you have deuteros, you can go to the local heavy water bank and pull some heavy water out to run your car or power your house or do whatever. So
The things that you need to run your device are easy to be found. They're not
yeah,
difficult.
it's heavy water. About 1 out of 7,000 molecules of hydrogen is a deuterium, and argon's 0.9% of the atmosphere, and oxygen, well, that's in the heavy water. We got plenty of that. Oxygen 18 burns a little bit better than oxygen 16, but still, you get that. That also gets concentrated in the heavy water. So yeah, so this is I mean, it's like decentralized energy, and you can take it. And what's really good is there's like a lot of those rare earth metals and other metals. Like we could do MOXY on you could do like they're always the Chinese cut America off from gallium and geranium, right? Well, you
Yeah.
could take MOXY and use iron or maybe nickel, and you can or chrome, and you can actually use MOXY and synthesize those. So
Well,
we don't
okay.
need your Chinese geranium and gallium. We could and what is it we can just do it ourselves.
And so, nothing that you're saying is all that complicated. We know that they have the Baghdad battery.
Mm-hmm.
Um, so we know they were generating electricity back 2000, 3000 years ago. What would stop like somebody from say, I don't know, the Middle East from 2500 years ago? Could they actually, if they had access to electricity, could they actually do this?
Well, I don't know. Probably well if they had, but I know like the Roundheads. I don't know if those people never heard about. Remember that mass contacts? I think we had a thing on this once
Oh
about.
yeah,
Yeah, that Stefano Breccia writes about as Bruno. They had this contact with these aliens, quote aliens, but
that are really old.
but they were paying their little human flunkies to go do various things for them in platinum, 1 ounce platinums. And
Huh.
so, but they could just, it's just kind of like the Indians. They bought Manhattan for $22 of beads.
Yeah.
These guys, they could just get basically some beach sand from granitic hills and turn it into platinum group metals and go do it. So, I mean, that's why I wonder about, did the Anunnaki really need, I mean, if you can synthesize gold so easily, why do you have them mine it?
It's a good
I
point.
don't know. Or maybe the Anunnaki weren't that smart. Maybe they hadn't figured it out yet. I don't know.
Yeah, sorry. No, I'm not buying that one.
So
Uh,
anyway, it's
so
figured out
they,
now. It's out there, and people are doing it all over the world. So that's and and we really have to say thank Osawa and Kushi, which showed us the very best way to do it.
Well, I encourage people to do it and to pursue it, and then let us know what's going on, because I'd like to hear what happens with all of this, and I might even get a group here where I live and examine some of this, because wow, electricity, they're shutting off all the coal power plants in Colorado. I think this year, 24 is the last year that we will have it. I don't know if they're going to tear them down or keep them in reserve in case they need them. I hope that's what they do.
Well, that's
Uh,
just it's insane.
that's insane. That's insane. One hailstorm hit Nebraska 2.5 weeks ago and destroyed 16 square miles of solar panels, right?
Yeah.
Yeah, so I mean, we have it here in southern Colorado. We're all solar panels out. We get gigantic hailstorms here in the summer. So I don't know. Yeah.
No,
That's
there's
why that's what really why I had you on, because we got it. The smart people among us have to start figuring out the way to decentralize on every level, because it's just going to get very, very serious. And with the number of people pouring into the country right now, things are going to get very dangerous.
oh
And
yeah, they're these are third yeah but they're the criminals and the underclass of
sure,
the dregs of society are rushing pushing in here. That's
oh,
why they're coming here, and then they're subsidizing them. But when the blank hits the fan, those subsidies will disappear
so,
along with the plastic in your wallet, and then it'll be mayhem and chaos from sea to shining sea.
and I mean, people don't want to bring this up, but if I was a poor dictator in a South or Central American country and all of this stuff was going on right now, I'd let everybody out of my jails. Why should I
Oh
pay?
yeah, and ship them south
Absolutely.
right in, ship them north
Every
right to United States, and all of a sudden you got the worst hardened criminals from around the world by
time.
the millions in your country.
Yeah, which is by design. So that would be the, I wonder why the Elohim want our country destroyed. It's very strange. But
Well, I mean, look at the right, and that's those it's been traced back to the Department of Defense. So the
all right,
DoD was actually 100% behind that.
all
And
right,
well, but I don't know if we could
absolutely,
say anything. We're probably getting
absolutely.
close to.
No, but let's talk about something that I think we can talk about without causing too many problems. And everybody, I'm going to put the links to the MOXY stuff. I want you guys to do that. It's really important. But they did the one thing that they can keep track of probably better than anything else in statistics is on births and deaths. And pretty much every country keeps pretty good statistics outside of China. And they keep good statistics too. They just don't tell us. And
Yes.
so you can actually access all of this. It's called all causal death, all causal mortality. And it's you can go on the internet and you can look and check every state, how many people died in say 1975, where they died, what county, how many died, right? This is a well-known thing, all right? And so you can go through and you can make a graph and you can look at spikes. So you can say, okay, let's look at 1995 Florida, all cause mortality. And you lay out your graph and you say, oh my God, in August, there was a big spike. 380 people, there was a 300% increase in deaths in the third week of August, right? And then you look and you see, oh, there was a hurricane that hit Florida. So there's a cause behind the spikes, is what I'm trying to get to.
Oh yeah.
Always. So you can go back through the statistics and see, and you can learn a lot. Tornadoes, you have spikes, and diseases, starvation in third world countries cause spikes, uh, droughts. This is a well-known science, right? Every single spike in the all-cause mortality statistics can be explained except for one, and that's
Yeah.
the one that happened in June of 2021. And by the
Mhm.
way, there was no rise in all-cause mortality in 2020 anywhere on Earth. It
That's
was
right.
flatlined.
It was like there was nothing happening at all. It's like
Nothing.
it really wasn't really something.
No, it's very odd. And then in June 2021, all-cause mortality begins to be a spike that would be attributed to World War II.
Yeah. Oh yeah. And I was looking at they came out with some Australian stats,
Yep.
and they're saying, I think it's either the first or second cause of death now is unknown in Australia.
Unknown.
And before it was like number 15. And so like one or two, the main leading cause of death in Australia is unknown. Actually, I think it is known, but they just don't want to say what it is.
Well, yeah, and I'm also noticing that there's a lot of people dying right now, of course.
Oh, huge. I
Everybody.
mean, I've so many people. I mean, I know I could count at least a dozen people that I know in extended things that have
Absolutely.
gone
My
prematurely.
little small town, every week there's another poster up with another one. And they're not old, or a lot of them are regular 40-year-olds and things like that. And I've noticed that and maybe it's because I live in a poorer place, but it looks like they're not really doing autopsies on a lot of these people anymore. I guess that's not required anymore because they really just kind of write off the death, and you try to find out what the cause was, and there is no cause. They don't really ever really tell you in the obituary or anywhere. And I'm like, okay, so they're not even bothering anymore. They're just like, oh, they died. That's it. Let's go next. And
Yeah.
I don't know.
Yeah. Then like a lot of the actuaries for insurance companies, they have to keep really good stats because they're
They
paying the
do.
bills, and I think what was the guy saying? It's like the variance off of what it used to be is like a sigma 14 or something event, some
Absolutely.
insane level. But actually, if you look at those insurance companies, they have really tight margins.
They do.
And
They're going to go
frankly,
out
what's
of business.
happening is going to cause the collapse of the insurance industry, the life insurance industry, I should say.
I'm going to say all insurance companies because they're all interchanged and interlocked.
Yeah, they are.
One starts going, they start pulling all the other ones down. And, I'm I'm actually hearing from actuaries who, by the way, are very worried about losing all their jobs to AI. Actuaries telling me that um, uh, house insurance could be like $3,000 a month in the future. He says,
Yeah, that would just totally destroy it because if you don't have insurance, you can't have a mortgage, but
"Yep,
it would be, yeah.
yeah." So the all-cause mortality statistics are really a cause for concern, but nobody's reporting it in any major media. Um, in other words, what I'm trying to say, and then I'm close out here, is that these statistics show that since June of 2021 till now, we have had a rise and a spike in mortality akin to the Spanish flu outbreak and World War II. In other words, the two biggest spikes of the 20th century happened in June 2021 with no visible cause.
And
There's,
it's still going on.
that's right.
It's
There's
it's not
we
going
don't
down.
know what happened in June 2021 that caused this to happen. And it's the greatest mystery, probably, maybe even in history. And so it's something that we all need to think about and talk about, I think.
Yeah. It's just, one of those things right in your face. And that's not the
Yep.
only one, that's for sure.
No, and if there's any investigative journalists out there, this is a great story to look into. We got to find out why this is going on and report it because it's still going, and it's really a really important story, and nobody's asking why this is happening, and we're all losing friends and family. So it's a concern to all of us. All right, Ken, I'm going to go now, and I want everyone to look at the links. I'm going to put them below how we can get this MOXY thing going and get a revolution in energy, which is the whole reason I'm doing this show, going because it's time for the great um, the great decentralization of the world. And you know, and I feel sorry for the people that are getting trapped in the cities right now, because they're going to what's going to happen here is, with the hiring practices that are going on now, somebody is going to pull the wrong switch somewhere, somehow, and it's going to cause a gigantic disaster. I have no idea what switch it's going to be pulled, how it's going to happen. I can only tell you that somebody somewhere is going to pull the wrong switch here soon, because they're not qualified for the job that they're doing.
Yep.
Anyway,
And be careful where you sit in the airplane.
I'm not flying. All right, Ken. Thanks for coming on. I'm Jay Weidner, Reality Check. Thanks for watching, and I'll be back with another show, I hope, soon.